Myself, Ketan Patel from Mahatma Gandhi Institute of Technical Education and Research Center, Navsari, Electrical Engineering Department, Disaster Management subject, third year, 5th semester, chapter number 2, Types, Trends, Causes, Consequences and Control of Disasters. Okay, syllabus content. First is hazards of hailstorm, snow avalanches and its types, causes of snow avalanches, preventions and mitigations of snow avalanches, drought and its types, causes and effects of drought, and drought management. Okay. First is hazards of hailstorms. Okay, what is hailstorm? Okay. Hail is a form of solid precipitation. It is distinct from steel. The two are often confused for one another. It consists of balls or irregular lumps of ice, each of which is called a hailstorm. Sleet falls generally in cold weather, while hail growth is greatly inhibited at cold temperatures. Okay. Hazards. Hail can cause serious damage, notably to automobiles, aircraft, skylights, glass roofed structures, livestock, and most commonly farmers' crops. Hail damage to roofs often goes unnoticed until further structural damage is seen, such as leaks, or hardest to recognize hail damage on single roofs and flat roofs. But all roofs have their own hail damage. Detections problems. Metal roofs are fairly resistant to hail damage, but may accumulate cosmetic damage in the form of dents and damaged coatings. Hail is one of the most significant thunderstorm hazards to aircraft. When hailstones exceeds 0.5 inches or 13 mm in diameter, planes can be seriously damaged within seconds. The hailstones accumulating on the ground can also be hazardous to landing aircraft. Hail is also a common nuisance to drives of automobiles, severely denting the vehicle and cracking or even shattering windshields and windows. Wheat, corn, soybeans, and tobacco are the most sensitive crops to hail damage. Rarely sensitive hailstorms have been known to cause concussions or fatal head trauma. Hailstorms have been the causes of costly and deadly events throughout history. One of the earliest recorded incidents occurred around the 9th century in Rukun, Uttarakhand in India. Okay. These are some examples of hailstorms in different locations, in road, in houses, in gardens, etc. Next is snow avalanches and its types. The snow avalanches, a common occurrence is snow-covered mountains regions, is a slidely of snow mass down a mountain side. This is the rapid downslope movement of a large detached mass of snow, ice, and associated debris, such as rocks and vegetables. Small avalanches or subs occur in large numbers, while large avalanches that may encompass slopes a kilometer or more in length with millions of tons of snow. Humans have been exposed to the threat of the sliding snow for as long as they have inhabited mountainous regions. A large avalanches can run for many kilometers and result in massive destructions of forest and anything else that comes in its way. Next, we discuss about the types of avalanches. First is types is loose snow avalanches, slab avalanches, avalanches composed of raw snow, wet snow avalanches. First is loose snow avalanches. There are two basic types of avalanches: raw snow avalanches and slab avalanches. These are the further subdivided according to the whether to snow involved is dry, damp, or wet. Whether the snow slide originates in a surface layer or involves the whole snow cover, like slide to ground, and whether the motions in the ground, in the air, or mixed. In loose snow avalanches from a snow masses with little interconnections among the individual snow crystals. When such snow lies in a state of unstable equilibrium on a sloped table, then its natural angle of repose. Slight disturbance sets progressively more and more snow in downhill motion. If enough momentum is generated, the sliding snow may run out into the level ground or even scan an opposite valley slope. Such an avalanche originates at a point and grows wider as it sweeps up more snow in its descent. In slab avalanches originate in snow with sufficient internal cohesion to enable a snow layer or layers to react mechanically as a single entity. The degree of this required cohesion may range from very slight in a phase, new snow, to very high in hard, fine draped snow. Slab avalanches breaks free along a characteristic fractures line, a sharp division of sliding from stable snow whose face stands perpendicular to the slope. In avalanches combined of dry snow usually generate a dust cloud when the sliding snow is whirled into the air. Such lights called powder snow avalanches most frequently originate at soft slabs. In wet snow avalanches move more slowly than dry ones and are seldom accompanied by dust clouds. Their higher snow density can lay them enormous destructive force in spite of lower velocities. As wet slides reach their deep position zone, the interactions of sliding and stranded snow produce a characteristic generalism. So there are the different snow avalanches. This is an example of different types of snow avalanches. Now, causes of snow avalanches. Avalanches from as soon as the force of gravity on the snow cover exceeds its mechanical strength. To be caused, an avalanche needs to steep slope, snow cover, a weak layer in the snow cover, and the trigger to initiate movement. Snow avalanches may occur on any slope where enough snow is deposited in the right circumstance. Snow does not accumulate significantly on steep slopes. Also, snow does not flow easily on the flat slopes. Most avalanches of dangerous size therefore originate on slopes with an inclination at between 30° and 45°. On slope from 45° to 50°, slopes and small avalanches are common, but snow seldom accumulates to sufficient depth to generate large snow slides. Convex slopes are more susceptible to avalanches than convex slopes. Avalanches are released by an increase in stress and or decrease in strains. So internal metamorphism or stress development may sometimes initiate a snow rupture. Avalanches are often dislodged by external triggers. Ice fall, falling chronics, earthquakes, rock falls, thermal changes, blizzards, and even other avalanches are common natural triggers. Here the wind is direction is this type, okay, and snow, and this is a weak crust layer, okay, this is a layer of different snows, the different layer, and so this is the move down to the downward, okay, same type in this figure, and this is the hanging glaciers release areas, okay, this is a roadstock rates release areas equal W phase. Avalanches can also be triggered by loud sounds such as shouts, machine's noise, and sonic booms. In the absence of external triggers, unstable snow may revert to stability with the passage of time as long as avalanches occurs. The rheology of snow cover is similar to the that ice, as both are viscoelastic materials that exhibit creep behavior over time. Snow deforms continuously without friction as the load on top of it increases. However, the loading rate is critical. Heavy snowfall over a short durations leads to a greater probability of avalanches occurrence. Snowfall of 1 m in one day is more hazardous than 1 meter over the 3 days. When the snow peak becomes unstable, it is released suddenly and descends repeatedly down the slope, either over a wide area concreted in an avalanche track. Avalanche reach speeds of up to 200 km an hour and can exert forces great enough to destroy structures coming in their way and uproot or snap off large trees. It may be preceded by an air blast capable of damaging constructions and forest cover. Next one, prevention and mitigations of snow avalanches. Obviously, the most desirable and effective protections against avalanches is to situate buildings, roads, and other valuable development projects in area free from avalanches. However, as the population grows and more hazardous sites are considered for development, advanced planning and strictly enforced zoning and construction particles appear to be the best solutions. In some cases, even these are not adequate to completely climate the risk of avalanches. An acceptable risk must be defined, especially in the case of roads, power lines, and railroads. These risks can, however, be reduced considerably if appropriate structural controls are employed. Here, the management of landslides and snow avalanches, different points. Like first is landslide hazards, vulnerability and risk assessment, multi-hazard concept utilizations. Okay, landslide remedies, practice, research and development, monitoring and early warning, knowledge network and management, capacity buildings and training, public awareness and education, emergency preparedness and response, and regulation and enforcement. Since avalanche prone area can be identified, the safest and probably the best mitigation procedure is to avoid construction of buildings or any type of structure involving winter use in this area. Agriculture and recreational activities that take place during the non-avalanches month are relatively safe. Other uses that could be considerable are those that do not involve permanent unprotected structure in the avalanche path, or those that could be moved or closed down during high avalanche risk periods. Okay. Engineering structure for the control of snow avalanches are of the following four types. First is supporting structure in the starting zone built on the upper part of the avalanches path to prevent avalanches from initiating, or to rotate movement before its gain momentum. Massive earth or stone walls and terraces. Rigid structures made from wood, steel, aluminum, pre-stressed concrete, or a combination of this material. And flexible supporting structures called snow railings, constructed of steel cables or nylon straps and held up by steel poles, are example of this. Second one is deflecting and retarding structures in the run-out zone to keep the moving snow of an avalanches away from structural is critical locations. These are the massive structures usually made of earth, rock, or concrete located in or near the avalanche track or run-out zone. Third one is retarding structure are usually earth mounts or large concrete structures called breakers or tripods. The additional roughness and cross currents set up by these structural usually stop all but large dry snow avalanches. And fourth is direct protection structure are built immediately adjacent to the object to be protected, or in a few cases incorporated into the design of the object itself. Avalanche shades or shelters are merely roof over roads or railroads that allow avalanches to cross the railroad without interrupting or threatening the traffic. This is the prevention and mitigation of snow avalanches. Now droughts. What is drought? Okay, and its types. A drought is an extended period of months or years when a region notes a deficiency in its water supply, whether surface or underground water. Generally, this occurs when a region receives consistently below average perceptions. It can have a substantial impact on the ecosystem and agriculture of the affected region. Although drought can persist for several years, even a short, intense drought can cause significant damage and harm the local economy. Types of There are four types of drought. First is meteorological drought, agricultural drought, hydrological drought, socio-economic drought. Meteorological drought is it is expressed slowly on the basis of degree of dryness in comparison to some normal or average amount and the duration of the dry period. It is brought about when there is a prolonged period with less than average perceptions. Meteorological drought is generally defined by comparing the rainfall in a particular place and at a particular time. With the average rainfall for the place, meteorological drought leads to a depletion of soil moisture and this has an impact on crop productions. Reduced perceptions like less water enters ground. Okay. Higher temperature and winds, lower relative humidity, greater sunshine is increased water loss from plants and oceans. Okay. When they define drought this way, we only consider the reductions in rainfall amount and don't take into account the effects of the lack of water on water reservoirs, human needs, or on agriculture. Meteorological drought usually breeds the other kinds of drought. The intensity and durations are the key characteristic of this type of drought. Now, add agriculture drought. Agriculture drought occur when there is not enough water available for a particular crop or grow at particular time. The drought does not depend only on the amount of rainfall but also on the correct use of water. Imagine a period of low rainfall where water is used carelessly for irrigations and other purposes. Under this circumstance, the effect of the drought becomes more pronounced than it was before. Agricultural drought is typically seen after meteorological drought when rainfall decreases, but before a hydrological drought when the water levels in reservoir, rivers, and lakes decreases. So, agriculture drought affects crop productions or the ecology of the range. Okay. In agriculture drought, reduces soil moisture, crops suffer, reduces yields. Now, hydrological drought. It is brought about when the water reserves available in sources such as aquifers, lakes, reservoirs, river fall below the statistical averages. It is associated with the effects of periods of perception shortfall on surface and subsurface water supply rather than with perception shortfalls. Hydrological droughts usually are noticed sometime after the occurrence of meteorological and agricultural drought because more time elapses before perceptions deficiencies are detected in reservoirs, groundwater, and other components of hydrological systems. As a result, impacts of hydrological drought are out of phase with impacts of other drought types. Also, water and type hydrological storage systems such as reservoirs, rivers, and groundwater often is used for multiple and competing purposes, further complicating the sequences and quantifications of impacts. Water uses affected by drought can include purpose as varied as power generation, flood control, irrigations, drinking water, industries, and recreations. Next is socioeconomic drought. Socioeconomic drought associates the supply and demand of some economic good or service with elements of meteorological, hydrological, and agricultural drought. In socio-economic drought, deficiencies of perceptions are linked directly to the supply of some commodity or economic good, for example, water, hay, or hydroelectric power. Increase in populations can other substantially the demand for these economic goods over time. So this is the types of drought. Now, causes and effects of drought. The various causes of droughts are: first is amount of water vapor in the atmosphere. Amount of water vapor in the atmosphere is the most important cause of drought, as it creates perceptions. More rain, sleet, hail, and snow can occur while there is a moist, low pressure air system. If there is an above average presence of dry, high pressure air systems, instead, less moisture is available to produce perceptions, because dry, high pressure air systems cannot hold as much water vapor. Second, shifting of air masses. When winds shift air masses and warm, dry, continental air moves over an area opposed to cooler, most oceanic air masses, the area suffered a drought. Third one is cold and warm water ocean currents. Unusual currents of cold and warm water in the ocean can also create a high pressure system. In the Pacific Ocean, a warm water current known as El Nino brings low pressure systems that cause hurricanes and other violent storms to North America. On the other hand, the cold water currents known as La and Nina brings drought. In Asia, the opposite occurs, with Nino bringing drought and the reverse airflow causes drought in India. Mountains. Higher mountain ranges near oceans are also responsible for drought on the leeward side of the mountains. Moisture located wind blowing from ocean surface to the land strikes the barriers like mountains, rise up, becomes colder, and the vapor considers into rain on the windward side. When the air masses passes over the mountain, it has lost much of its vapor. Hence, the leeward side gets very less rainfall. Human activities. Human activity can directly trigger exacerbating factors such as deforestation for agriculture, over farming, excessive irrigations, construction of building, etc. Adversely affect the ability of the land to capture and hold moistures. Activities resulting in global climate change are expected to trigger droughts. Global warming. Overall, global warming will result in increased world rainfall, along with drought in some areas and flooding and erosions in others. Now, effects of drought. Drought produce a large number of impacts that affects the social, environmental, and economic standard of living. Its effects spread far beyond the physical effects of drought itself. Water is integral to produce goods and provide certain services. Some direct consequences of drought are reduction in crop yield, reduced water levels, increased livestock and wildlife death rates, damage to wildlife and fish habitat, increased price for food, unemployment, migrations, etc. The many effects of drought can be listed as three types. First is economic, environmental, and social. In economic, loss of national economic growth, slowing down of economic development, damage to crop quality, less food productions, increase in food prices, increase in importance of flood, insect infestations, plant diseases, loss from dairy and livestock productions, increased predation, range fires and wildland fires, damage to the fish habitat, loss from fishery productions, income loss for farmers and other affected, unemployment from productions declines, loss of recreational and tourism industry, loss of hydroelectric power, and loss of navigability of rivers and canals. So there are the numbers of features in economy. Now environmental. In environmental, increase desertifications, damage to animal species, reductions and degradation of fish and wildlife habitat, lack of food and drinking water, disease, increased predictions, loss of wildlife in some areas and too many in others, increased stress and endangered species, damage to plant species, increased number and severity of fires, and fire and water erosions of soil. And third one is social. In social, food shortages, loss of human life from food shortages, heat, suicides, violence, mental and physical stress, water user conflicts, political conflicts, social unrest, public dissatisfaction with government regarding drought response, okay, loss of cultural sites, and increase in poverty. So these are the effects of drought. Next, drought management. Many of the management alternatives available to water supplies to prepare for and respond to drought events fall into two broad categories. First is demand management and supply management. In demand management, public informations and education campaigns, emergency conservation programs, water services restrictions on non-essential uses of water, prohibitions of selected commercial uses, drought emergency pricing, water rationing programs, augmentations, improvements in water supplies, like example of leak detections, lining of transmission canals, etc. Emergency sources supply, for example, emergency interconnections, drilling new wells, management of available water resources, for example, emergency water banks, overdrafting, and groundwater aquifer. Search for new supplies of water. In summary, increased emphasis can and should be placed on drought mitigations and preparedness. Okay, this is the monitoring and preventions with connected declaration and response, mitigations and preparedness. Okay, this is the circle. In summary, increase as well as the predictions and early warning capabilities is society is to reduce the economic and environmental damage associated with drought and its personal hardships. This will require interdisciplinary cooperations and a collaborative effect with policymakers at all levels. Drought protections and relief. Strategies for drought protections, mitigations, or relief include like a dam. Many dams and their associated reservoirs supply additional water in times of drought. Cloud seeding, an artificial technique to induce rainfall. Desalinations of seawater for irrigations or consumptions. Drought monitoring, continuous observation of rainfall levels and comparisons with current usage levels can help prevent man-made drought. For instance, analysis of water uses in Yemen has revealed that their water tube underground water level is put at grave risk by overuse to fertilize their cut crop. Careful monitoring of moisture levels can also help predict increased risk for wildfires. Using such metrics as the Kutch Behram Drought Index or Palmer Drought Index. Land use. Carefully planned crop rotations can help to minimize erosions and allow farmers to plant less water dependent crops in dry years. Outdoor water. Use restrictions regulating the use of sprinklers, house hoses, or buckets on outdoor plants, filling pools, and other water intensive home maintenance tasks. Rainwater harvesting. Collections and storage of rainwater from roofs or other suitable catchments. Recycle water. Form of wastewater that has been treated and purified for reuse. Okay, so these are the technique to avoid the drought. Okay, so protection is very important in the theory of drought. These are the schematic description of drought management cycle in India. Okay, monitoring, declarations, response, preventions, mitigations, and preparedness. Okay. Thank you.